In this session, we will be learning on how to determine the degrees of freedom of a parallel manipulator. So we'll be using the Gribler's formula. So in general, it is not so easy to determine the uh, degrees of freedom of closed loop kinematic chain. But classical mobility formula, that is the Gribler's formula, can be used. So here you have two formula, that is one is the Gribler's formula for spatial manipulator, and another one is the formula for planar, right? So here degrees of freedom, it is equal to 6 into n minus 1 minus summation I equal to 1 to g 6 minus fi, or you can use degrees of freedom as 6 into n minus g minus 1 plus summation I equal to 1 to g fi, where n denotes the number of links or the rigid bodies of the mechanism, number of links or the rigid bodies of the mechanisms, including the base, right? So including base, that is very important, including base. And G refers to the number of joints. G refers to number of joints. And Fi refers to the number of degrees of freedom of each joint. Number of degrees of freedom of each joint. Right? So as you know, a revolute joint, it has 1 degree of freedom. Prismatic joint, it has 1 degrees of freedom. A spherical joint, it has 3 degrees of freedom. So this degrees of freedom of each joint is denoted as Fi. Right? Then if it is a planar manipulator, we'll be using the this formula to find the degrees of freedom, that is 3 into n minus g minus 1 plus summation I equal to 1 to g fi. Now we will see how to determine the degrees of freedom of few parallel manipulators. First, we will start with the planar example. So here for the first example, as you see, we have the number of links including the base as 3. So this is base is as link 1, link 2 and link 3, and you have also 3 joints. So this is joint 1, joint 2, joint 3. So you have 3 links and 3 joints. So the degrees of freedom would be 3 into n minus g minus 1 plus the summation of the individual degrees of freedom of each joint, right? So I equal to 1 to g. So it is 3 into n is 3 minus g is 3 minus 1 plus summation I equal to 1 to 3. So each joint is having a degrees of freedom of 1, right? So the all are revolute joints, and as you know, the revolute joint degree of freedom is 1, right? So it will be Fi. So it will be 1 plus 1 plus 1. So that is 3. So that is why here you get 3, right? So when you just solve this, you will get the degree of freedom to be 0 for this planar manipulator, right? So the next example, so again you can see, so including the base, you have 5 links, that is 1, 2, 3, 4, and end effector, that is a link. So 5 links you are having, and how many joints? It you have 6 joints. So this is 1, 2, 3, 4, 5, and 6 joints you have, right? So when you just substitute in the formula for degrees of freedom, you will be having 3 into 5 minus 6 minus 1 plus. So each joint is having a degree of freedom of 1. So you have 6 joints. So it will, on summing it up, you will be getting as 6. So when you solve this, so you will be getting the degree of freedom of the manipulator to be 0. Then the third example, you have 3 links including the base and 3 joints. So this is a prismatic joint and two revolute joints you have. So the now on substituting, you will be getting the degree of freedom of this manipulator to be 0. So again, I have few more examples for planar manipulator here. So you can try it out by yourself, and you can check the answers here, right? So it is of the same pattern. Next, we will see how to determine the degrees of freedom of a spatial planar manipulator. So the figure shows a spatial planar manipulator. So the important thing to note here is that so you have to check if all the whether the all the joints are active. That is, if at all you have any passive joints, then while calculating the degrees of freedom, that particular joint should not be included, right? So you have to subtract the number of passive joints to the DOF formula, right? So here, as you see, this is in this manipulator figure shown, you have 8 links, that is 1, 2, 3, 4, 5, 6, then including the base 7 and 8, right? And you have 12 joints. So you have this in each 6 links here. You have two joints connected. So it is a binary link with the two spherical joints. So a binary links is formed by connecting with two spherical joints. So you have 12, totally 12 joints, right? So as you know, the degree of freedom of each spherical joint, it is 3. So F5, you have to just get 12 into 3, right? So on substituting in the formula, because it is a spatial manipulator, the formula is now changed. That is, it is 6 times. So 6 into number of n minus g minus 1. So that is 8 minus 12 minus 1 plus this is the since the sum of I equal to 1 to gfi, so the degrees of freedom of each spherical joint, and you have subtracted the idle joints or the passive joints from in order to find the degrees of freedom. So you have subtracted 6 from the total degrees of freedom. Okay, so that you will be getting the degrees of freedom of this manipulator to be 0.